Good morning, students. This is the next topic and also last topic of amines. Actually, this topic is not there in this year in CBSE, but in competitive level, this is very important topic. One of the important topic, basic nature of amines. That means amines having basic nature. Why amines having basic nature? See, if you observe one point, then you get a clear idea about that one. That is RNH2. This is primary amines. RNHR secondary amine. RNR the tertiary amine. We know that very well. In case of nitrogen, whenever nitrogen forms three bonds, see, this nitrogen forms this side one bond, this two hydrogens means it forms two bonds with two hydrogens. That means whenever nitrogen forms three bonds, it is having one lone pair of electrons. Here also nitrogen forms three bonds, one left side, one right side, one with the hydrogen. So here also it is having one lone pair. Here already we can see three bonds formed by nitrogen. Automatically it is having lone pair of electrons. Whenever an atom having lone pair of electrons, it can donate those lone pair of electrons to other substance, so that it is having basic nature. Strictly says that it is Lewis base. So what is the point? Amines having basic nature due to the presence of lone pair of electrons. Next, one more point. This is what cyclohexane. This is benzene. This is aniline, nothing but aromatic amine. Aniline, A-N-I-L-I-N-E, aniline. This is also called aromatic amine. This is here also nitrogen forms three bonds, one bond with carbon of benzene ring and two bonds with hydrogens. So it is also having lone pair of electrons. Whenever nitrogen forms three bonds, automatically that nitrogen having lone pair of electrons. Next, here in this case, these lone pair of electrons involves in resonance structure. So aniline can exhibit resonance structure by gaining those lone pair of electrons. Then this bond transfers to this carbon atom. Then here negative charge appears, here positive charge appears, because this nitrogen loses lone pair of electrons. Again, this compound can exhibit one more resonance structure. So what is our point here? Here these lone pair of electrons are not free in aromatic amines. In aromatic amines, these lone pair of electrons are not free because of involving resonance structures. So what is the point here? These aromatic amines cannot give lone pair of electrons to other substance. So they are having less basic nature compared to aliphatic amines. These are aliphatic amines, these are aromatic amines. So what is the point here? Aromatic amines are less basic than aliphatic amines. One more point, NH3, this is what? Ammonia. These are aliphatic amines, these are aromatic amines, this is ammonia. It is also having lone pair of electrons. Here electron donating groups are present. That means what? These donates electrons to nitrogen atom, then those nitrogens readily gives electrons to other substance. So what is the point here? Aliphatic amines are more basic than ammonia. Which is more basic than aniline? Aliphatic amines are more basic than ammonia, which is more basic than aromatic amines. See, those are the points already mentioned here. Aromatic amines have less basic than ammonia, which also have less basic than aliphatic amines. Next, aliphatic amines have more basic nature than ammonia and aromatic amines due to the presence of electron donating groups, that is alkyl groups. Next, aromatic amines have less basic due to absence of free lone pair of electrons on nitrogen atoms, since the lone pair of electrons involves in resonance structures. We discussed already these points. Next, basic nature of aliphatic amines. Now we discuss about aliphatic amines basic nature. It can be explained by three factors. Among them, first factor is plus I effect. Plus I effect means plus inductive effect. That means according to plus I effect, if number of alkyl groups increases, then basic nature also increases, as I told here. in this point. If number of alkyl groups increases, automatically basic nature increases. Hence tertiary amines are more basic than secondary, which is more basic than primary, which is more basic than ammonia. See here, number of alkyl groups are 3, automatically it is having more basic. Here 2 alkyl groups, then this comes first after tertiary. This is the last among primary, secondary, tertiary, and last one ammonia. That is according to plus effect. Next, one more factor is there, that is hydrogen bonding. If number of hydrogen bonds increases, then basic nature also increases. If number of hydrogen bonds increases, then basic nature also increases. See here 2 hydrogens attached with nitrogen, so here number of hydrogen bonds are 2. Here only one hydrogen is attached with nitrogen, so here only one hydrogen bond is possible. Here no hydrogen is attached with nitrogen, so here no hydrogen bond is possible. So what is the point here? If number of hydrogen bonds increases, basic nature also increases, because if number of hydrogen bonds increases, then attractions between this hydrogen and nitrogen of another molecule increases. Then these lone pair of electrons somehow free, then this molecule readily loses these electrons to other substance. I repeat this point once again, listen carefully. See, when RNH2 forms hydrogen bond with other molecule, it looks like this. Then hydrogen bond is formed between this hydrogen and this hydrogen, and this hydrogen and another molecule. Then these molecules comes close to each other, then these lone pair of electrons somehow free, then immediately this molecule donates these lone pair of electrons to other substance easily, then automatically basic nature increases. So according to hydrogen bond concept, which is having more basic nature? Primary greater than secondary greater than tertiary. Compared to primary, NH3 is having more basic nature according to hydrogen bond. According to plus effect, this is the order. According to hydrogen bond, this is the order. That means here that is exactly opposite order. See, NH3 greater than, primary greater than, secondary greater than, tertiary. And last factor is what? Steric hindrance. Steric hindrance means repulsions between bulky groups. If bulky groups, nothing but alkyl groups, increases around the nitrogen atom, then it cannot donate the lower pair of electrons to other substance. I repeat this point once again, listen carefully. If alkyl groups increases around the nitrogen atom, then that nitrogen cannot donate lone pair of electrons to other substance easily. See, this is a primary, this is secondary, this is tertiary. Here 3 bulky groups are present, here 2 bulky groups, here 1 bulky group. If number of bulky groups are present, then steric hindrance increases, so this nitrogen cannot donate these lone pair of electrons to other substance according to steric hindrance concept. So this will be having less basic nature compared to this. This will be having less basic nature compared to this. This will be having less basic nature compared to ammonia. So according to steric hindrance concept, again order is same as in hydrogen bonding. That means see, NH3 greater than, primary greater than, secondary greater than, tertiary, same order as in hydrogen bond. So based on these 3 concepts, we can say basic nature of amines. Now if you observe the orders are different. These orders are same, but these orders are exactly opposite to plus effect. So based on these 3 factors, we can give 2 orders. They are secondary greater than, primary greater than, tertiary greater than ammonia. That is one order. Secondary greater than, tertiary greater than, primary greater than ammonia. That is another order. This is the order for alkyl group having methyl group. That means when methyl group is present, then we have to follow this order. Otherwise, we have to follow this order. In gas phase means in gaseous state, there is no repulsions between alkyl groups. Then if number of alkyl groups increases, basic nature increases. So in that case, we have to follow this order: tertiary greater than, secondary greater than, primary greater than ammonia. This is about basic nature of amines. Some more points are there regarding this one, that is, if electron donating groups present on benzene ring, then basic nature increases. because if electron withdrawing group is present, acidic nature increases. If electron donating group is present, basic nature increases. See, if you observe these three compounds, here basic nature is due to presence of nitrogen. Here this is electron withdrawing group, here this is electron donating group, alkyl group. Automatically this is having more basic nature compared to this one. Here electron withdrawing group is present, so automatically it is having less basic nature compared to here. If electron withdrawing group is present, basic nature decreases. So this is about basic nature of amines. This is all about amines. With this topic, our total organic chemistry chapter is finished. Still we are having only one chapter, that is biomolecules chapter. It will start in next video. Thank you.